Good afternoon everyone, my name is Marellen Taclindo and today I will be discussing about Chapter 9, Discrimination and Deaths. So this will be the continuation of Ms. Bindio's discussion. So what is discrimination and deaths? Discrimination and deaths is basically an item statistics that can help us reveal useful information for improving an item or questionnaire. It shows the relationship between the student's performance and an item and helps us tell the difference between students who did well and did not overall. And high discrimination index means the better the question separates strong and weak students. So the discrimination index has a rule or nature. So as I've mentioned earlier, the higher the discrimination, the better. This means when the higher group scored higher, it means that the questions were good or reliable. But if the lower group scored higher, the lower the discrimination is. That means the questions were tricky and may need revision or may have been shut. Other than the rule or nature of the discrimination index, there are three possible outcomes. So the possible outcomes is positively discriminating item. Proportion of high group is greater than that of the low scoring group. So this means that the discrimination index is positive. This means that when the discrimination index is positive, that means the higher group is this means that the higher group scored higher. And next is the negatively discriminating item. Proportion of high scoring group is less than of the low scoring group. So, and next is the not discriminating. Proportion of high scoring group is equal to that of the low scoring group. So this means that the upper and lower groups are equal in having the correct or choosing the correct answer. So in calculation of discrimination index, therefore requires obtaining difference between the proportion of the high scoring group getting the item correctly and the proportion of low scoring group getting the item correctly. So there are multiple methods that we can use in obtaining the calculation of the discrimination index. So first I will discuss the first formula, which is D is equal to RU over TU minus RL over DL. So where D is the item discrimination, RU is the number of the upper group who scored or got the correct answer. TU is the number of upper group or the total of the upper group. RL is the number of lower group getting the correct answer. And TL is the number of the total number of the lower group. So I will give an example of how to do this formula. So an example of this is that you tested 10 students. You divide them into two groups, which are the upper group and the lower group. Both the upper and lower group have 5 participants or students. So in the upper group, 4 students got the correct answer, while the lower group got 2 students who got the correct answer. So when we put this into the formula, so RU is equal to 4 and TU is equal to 5, RL is equal to 2 and TL is equal to 5. So D is equal to 4 over 5 minus 2 over 5. So you divide both 4 over 5 and 2 over 5, and that is equal to 0.8 and 0.8 and 0.4. So D D is equal to 4 over 5 minus 2 over 5. It is equal to 0.8 minus 0.4. Then you subtract 0.8 and 0.4. So the answer is 0.4. So that is an example of the first formula. So the answer is D is equal to 0.4. And 0.4, later we will know how, or later we will know if how can we determine if the discrimination index is positive or negative. So next, there is also another formula that has a similar result to the previous example that I gave. So the next formula is D is equal to RU minus RL over T. So D is still the discrimination index. RU is the number of students in the upper group who got the correct answer. And again, RL is the number of students in the lower group who got the correct answer. And T is the number of students in either group. So the difference is that the total number of students in the number of the students in the either group is same. So an example of this formula, or an example that I can give you using this formula, is you gave a test to just 10 students and divide them into two groups, again, which is the upper group and lower group, who has 5 members either group. So 4 students from the upper group got the correct answer. 2 students from the lower group got the correct answer. So RU is equal to 4, RL is equal to 2, and T is equal to 5, since both the upper and lower group have the same number of participants or students. So D is equal to RU minus RL over T. So this is D equals to 4 minus 2 over 5, and then you subtract 4 and 2, so the answer will be 2 over 5. Then you divide 2 over 5, the answer will be 0.40. So that is how you do this formula. So again, I will give another formula, which is this formula is, as you can see that in the PPT, RT, R over T, is actually getting the p-value of an item. So to get D is to get the difference between the p-value involving the upper half and the p-value involving the lower half. So the formula for discrimination index can also be given as D is equal to PU minus PL. So PU is the proportion of students in the upper group who got the correct item. PL is the proportion of students in the lower group who got the correct item. So an example of this is the upper group. So the upper group have 5 students in total. So this is equal to TU equal to 5. And the lower group have 5 students in total, which is equivalent to TL equals to 5. 4 students in the upper group who got the item correct. So this is RU equal to 4. 2 students in the lower group got the item correct, which is the equivalent to RL equal to 2. So PU is equal to RU over TU. This is equivalent to 4 over 5. you divide 4 over 4 and 5, then and the answer will be 0.80. And then PL is RL over TL is the equivalent to this is 2 over 5. Then again divide 2 and 5 and you will have 0.40. And then when we extract this, the formula, this will be D equal to PU minus PL equal to 0.80 minus 0.40 equal to 0.4. So the answer will be D is equal to 0.40. So those are the three formulas that were indicated or stated, or examples that we can use in obtaining the discrimination index. And to find how many students in the top and bottom group answered correctly, the teacher does the following. So these are the steps to obtain the groups who answered correctly. So first, score the test papers using a key to correction to obtain the total scores of the students. Maximum score is the total number of objective items. Next is order the test papers from highest to lowest score. C. Split the test paper into halves, high group and low group. D. Obtain the p-value for the upper group and p-value for the lower group. P upper is equal to R over T. P lower is equal to R over T. And lastly, get the discrimination index by getting the difference between p value. So earlier, the answers were actually the answers of the formulas that I gave. The examples that I gave were 0.40, 0.40, and 0.4. So how do we determine, or how do we know if the discrimination index of those formulas are positive or negative or equal? So in the table 90.2 guidelines for evaluation the discriminating efficiency of items, for purposes of evaluating the discrimination power of items, POFEM 2011 offers the guidelines proposed by Abel and Frisbee 1991, shows in table 92.2 the teachers can be guided on how to select the satisfactory item and what to do to improve the rest. So the discrimination index is 4.40 and above is equal to the item evaluation very good items, and 0.30 to 0.39 is equivalent to reasonably good items but possibly subject to improvement, and 0.20 to 0.29 marginal items usually needing improvement, and 0.19 and below poor items to be rejected or improved by revision. So the guidelines for evaluating the discrimination efficiency of items help us determine whether the discrimination index is if the discrimination index result in those formulas that we used earlier are positive, negative, or equal. So the items with negative discrimination indices should be revised or removed. And in multiple choice tests, a negative D often means there's a problem with the question, such as wrong answer key, top students choose a better but unclear option, confusing or unclear questions, ambiguous choices that mislead informed students, correct answer is unrealistic, so top students avoid it. Following good item writing rules helps fix these issues. So basically the formulas and the discrimination index is a type of statistic item that help us review if the questionnaires or the items are reliable for the students to answer. So, other than the discrimination index, there is another way to identify items for improvement is the distractor analysis. If an item's difficulty and discrimination indices suggest revision, this analysis helps. So this basically distractor analysis is an item statistics method that helps us suggest the revision of or deletion of the items. It shows how high and low performing students respond to each option and checks if the distractors are working. Distractors rarely or never chosen, especially by weaker students, should be revised to make them more reliable. So, to illustrate this process, consider the frequency distribution of the responses of the upper group and the lower group across the alternatives for two items. Separate counts are done for the upper and lower group who chose A, B, C, and D. The data is organized in the disaster analysis table. So in the PowerPoint presentation, it is shown, or it is placed here, the table 9.3, the disaster analysis table. So I will explain each of the columns of the table. So item N equal 40 is the total number of participants. Difficulty index P 0.38, 0.45 is the proportion of students who got the correct item. Discrimination index is the discrimination index or the evaluation item. The one that I discussed earlier, which is the table 9.2, guidelines for evaluating the discriminating efficiency of items. So group is the, as what I mentioned earlier, the two groups, which is the upper and lower group. So the upper group is basically the more knowledgeable students, and the lower group is the less knowledgeable students. So the next column is the alternatives, which are A, B, C, and D. These are the options given in the test items. And the last one, omit, is the number of people or students who skip the question. So the table here shows an example. So first, the item or the total number of participants is 1. Difficulty index is 0.38, and the discrimination index is negative 0.35. Groups are the upper and lower group, and the alternatives A, B, and C, and the upper group who chose the option given in the test items. So in the upper group, 2 chose the 2 in the upper group chose A, 10 chose B, 5 chose C, 3 chose D in the upper group. In the lower group, 2 chose A, 0 chose B, 12 chose C, and 6 chose D. So as we can see in the table here, 5 has the asterisk sign, which indicates the correct answer. So in this item number, C is the correct answer. So in the difficulty index, it shows here that 0.38 proportion of students who got the correct answer. The discrimination index shows negative 0.35. So when we refer this to the table 9.2, guidelines for evaluating the discriminating efficiency of items, this is a poor item to be rejected or improvised improve or by revision, since it is negative 0.35. So basically, this item is not reliable. It may be misleading or tricky for the higher group students. So let's move on from that. So there is this will be the last approach, which is the sensitivity to instruction index. Another method is the sensitivity to instruction index, which is C or SI, which checks if students' performance improve after teaching. This means that this item statistics is a tool used to determine if the result after instruction is positive or negative. It's used through criterion reference test. SI or C compares pre and post-test p-values. A higher post-test p-value means the item was sensitive to instruction. That means when the post-test has a higher p-value, that means the sensitive to instruction or the instruction was efficient or effective. So this item statistics is used mostly to determine the difference of the outcome before and after instruction. A common way to do this is an pre-test and post-test. So in the textbooks, in this textbook, it also has a formula. So its p-value for the post-test is 0.80, while for pre-test is 0.10. Thus, SI or C is equal to 0.70 following this calculation. So SI, sensitivity to instruction, is equal to P post minus P pre. So in the given example, the percentage of the pre-test is 10% who got the correct answer, and the percentage of the post-test who got the correct answer after the instruction is 0.80, which is 80%. So this is equivalent to 0.80 minus 0.10. So the answer will be 0.70. So if the answer is 0.70, so this means that the discrimination item or the sensitivity to instruction is based on the table 9.2, wherein we are evaluating discrimination efficiency of items. It is a very good items. That means the question or the item is reliable, not tricky, and can be a positive outcome for determining the discrimination index or the sensitivity to instruction. So that will be the C works like the discrimination index. It shows how much student performance improved after instruction. A higher C means the item is a better reflex learning. If there's little change, it may be because the item wasn't taught or students already knew it. Teachers should review items such to check content coverage. So this will be the end of our topic, which is the chapter 9, and that would be all for my discussion. Thank you and have a good afternoon.